All right, what's up, guys? In this video, we're going to pick up some calculus here. We're going to be talking about infinite series, absolute and conditional convergence. So we have to determine if the given infinite series are given here basically converges absolutely, converges conditionally, or diverges. So basically what I've done here is I've already written down the conditions necessary for absolute and conditional convergence of a series. So what we have here, sorry for the noise in the background, I have my nephews are here making noise, so bear with me on that. But other than that, absolute and conditional convergence. So basically it says that if our series a sub k or a sub n, the absolute value of that series converges, then the series a sub k will converge absolutely. And then the other part says if the absolute value of our series a sub k diverges and the series a sub k converges, then basically our series a sub k will converge conditionally. And then we already know the criteria for whether or not it diverges based on what we've done in the past. So basically what we need to do is we need to identify what is the best test to use to determine whether or not this converges absolutely, conditionally, or if the series just flat out diverges. So when you get into a situation like this, if your professor doesn't already give you the answer in terms of telling you what tests you need to use, in most cases they will, because there's a lot of different convergence tests out there. But I'll give you a little bit of a hint. Anytime you see factorials flying around, it's probably a good idea to use the ratio test. Roots test, you can use that in certain situations as well. Obviously, when you have roots, you use the roots test. But you want to use the ratio test anytime you see factorials flying around, because they cancel out perfectly with that ratio test. So in this case, for this infinite series, we're going to use the ratio test, which is just another convergence test. It's one of the more common ones. It's one of the more common ones that you'll need to use, or that you'll be learning in Calc 2, especially once you start learning how to find, convergence of any particular type of infinite series. You might need to use that. So remember, for the ratio test, it basically says that L, which represents the limit, is equal to the limit as, in this particular case, n goes to infinity. Some books may have it as k. Please understand that it's basically the same thing. Some books use k, some books use n. And it's going to be the absolute value of a sub n plus 1 all divided by a sub n. And basically, using the ratio test, L again represents the limit. If the limit happens to be less than 1, then the series converges. If the limit is greater than 1, it diverges. Or if you get out infinity, or if you get out something that's infinite, diverges. Or let's say you get out infinity, then it'll diverge. And then if the limit is equal to 1, if you end up getting out 1 as your limit when applying this ratio test, then basically what it means is that the test is inconclusive. And basically all inconclusive means is that we don't know whether it converges or diverges. We just don't know. And you'll have to use a different test. So that's all the inconclusive part means. So we're going to use the ratio test here because we have factorials. So let's identify a sub n. So a sub n in our case, it's just n factorial all divided by 10 raised to the n. Okay. So let's use the ratio test here. So we'll have the limit, or L, is equal to the limit as n goes to infinity, absolute value of a sub n plus 1 all divided by a sub n. And basically all you do is every place you see an n, you plug in n plus 1. Then you gotta have the absolute value of it. So what we'll have is n plus 1 factorial, and that'll be all divided by 10 raised to the n plus 1, because every place I see an n, I have to put the n plus 1. Now I have to divide all of that by my a sub n. Your a sub n was the n factorial, all divided by the 10 raised to the n. Now remember, in this case, dividing by a sub n in this case is the same thing as multiplying by the reciprocal. So effectively, you can write this as the limit as n goes to infinity. And what you'll have is the absolute value of n plus 1 factorial, all divided by 10 raised to the n plus 1. We'll then multiply that by the reciprocal of the denominator, which is 10 raised to the n, all divided by n factorial, and that's absolute value. We can actually get rid of the absolute value bars here in just a moment. And now we just go through and we do some simplifying. So we can actually cancel some stuff out. The factorials will go, obviously. And so what we'll end up with in this case is the limit. And make sure that you're always writing the limit as n goes to infinity for every step, because some professors are sticklers on that. So what some professors will say is that if you don't write that every time, then that basically means that you already went ahead and took the limit, and they'll take a boatload of points off. If you do that. So if you do some simplifying, you have the absolute value of n plus 1 all over 10. Now, the limit as n goes to infinity for n plus 1 and for 10 is positive, or n plus 1 is positive as n goes to infinity, and so is 10. So effectively, you can remove the limits of integration. You can remove the absolute value bars. I'm thinking of integration. So you have the limit as n goes to infinity now. And what you have now, after removing absolute value bars, is going to be n plus 1 all divided by 10. So now you take the limit. So hopefully by this time, you get the Calc 2. You should be pretty good with limits at infinity by that time. That way you can be able to fly through this. So if we take the limit as n goes to infinity for n plus 1 all over 10, we just get infinity for that. Okay. Now, based on the ratio test, remember the ratio test says that if I get a limit that is less than 1, L represents the limit. If I get a limit that's less than 1, or is greater than 1, I'm saying less than 1, greater than 1, or if I end up getting something out that's infinite, then that basically means that my particular infinite series will diverge. So in this particular case, we get the limit is equal to infinity. So therefore, by the ratio test, this series just diverges. So by ratio test, the series diverges. So it's not going to conditionally converge. It's not going to converge absolutely. It just flat out diverges. So the final answer here is going to be diverges, or this basically the series diverges. And we prove that even further by using the ratio test. In some cases, you can again use the, looking for my marker, where is it? I don't know where my marker went. Oh, there it is. So in some cases, you can use the roots test. There's a whole bunch of different tests that you can use to see whether or not a series converges or not. But in this particular case, we use the ratio test. And this is basically how you get the answer. So I have some videos on this on my Instagram page. That's where all of my math videos are posted. I don't post very many videos at all on Facebook, but I haven't posted any in a while, so I thought I'd throw a few on here. So if you really, really want to see all of my content, please visit my Instagram page. I have pretty much over 1,000 videos on there that are streaming, and that you can go take a look at any time. But this is going to be your answer, and this is how you do this is absolute and conditional convergence. All right, guys, that's going to be it. I will see you guys next time.